Hey everyone, the Artificial Trainer here. Today I'm going to be going through some optimizations for Hunyuan video. These optimizations will go through how to use different amounts of VRAM for Hunyuan, and then also if you do have the VRAM available, what should you turn on and what should you turn off in order to get the best quality out of the generations. So I already have a pod spun up here. So these are the settings. We want the PyTorch 2.4 and most importantly the CUDA 12.4 image. You can see the container and disk volume sizes, and then just make sure you're exposing both port 8888 and 3000. All right, so let's connect here. On my Patreon, I have set up an install script for you already. So download this shell script. If you want to know how to install Hunyuan, then I have another video that you can go check out. I'll link it in the description below. But this shell script will just install it for you if you're on RunPod. It only takes about maybe 5 minutes. If you use Linux, this should work fine as well. It just won't work on Windows. But once we have ComfyUI installed, and if you're on Windows, you can follow along with the workflow. It should be the same in both Linux and Windows once the install is complete. All right, so let's install this shell script. The way we do that is with the command bash, and then just call the file. Let that run for about 5 minutes, and then we'll be back to open up ComfyUI. Okay, so our install is done. Now we just needed to go navigate to that port 3000. So we go back to our run pod, and when you click connect, you have the option to click for Jupyter Lab or this port 3000 HTTP service. Click on that one, and it'll bring us to ComfyUI. I have ComfyUI up, and first thing we're going to do is head over to my Patreon. I have a bunch of workflows in here, and find the workflow that works for your graphics card. The only one I don't have in here is 8 GB because I didn't have access to an 8 GB graphics card at the time, but you can start with the 6 GB and move up, or start with the 10 GB and move down until you can get it to fit in your card. So I'm gonna start with the 4 GB here. So I just downloaded the workflow, and all you need to do is drag it into the environment, and this is what we get. So just a little explanation of the workflow. If you don't know how to use Hunyuan, go back and watch my Hunyuan video, but just a quick refresher. So we load our text encoders up here. We load our model here. We have a block swap node, which helps with memory. And then we have, I'm using an anime lore that someone in the community created just as an example to show you how to use a LoRa. Okay, so this workflow should fit within a 4 GB VRAM card. The only downside is obviously you don't get a lot of frames, right? This is like a 1-second video. If you drop the resolution, you could get a little bit more. But I'm gonna talk through real quick all of the optimizations possible in this workflow so that you can hopefully understand this and kind of tweak the workflow to your needs, because there are a lot of variables in here, and I can't tell you, this is the best workflow to use, because sometimes some variable tweaks might be better for, an animated style. Some variable tweaks might be better for a real life person style. Yeah, so first thing to look at is this bar up here. This is downloaded by the Crystools custom node that we installed. So the biggest one we look at is this VRAM. Right now, I'd been running some workflows to test in the background, so I have some models stored in VRAM. I'm just going to unload those real quick, and that clears up my VRAM. So you can use this to monitor, check out, like, okay, I adjust my settings and my VRAM's only at 75%, so that means that I can either add some more frames or I can swap less blocks. And we'll get into what all of that means in a minute here. The other thing that's been added to Comfy, which is pretty cool, is a video preview. So if you go to the VHS settings here, there's a latent preview. If you turn this on, you'll see the video play in the Hunyuan video sampler as the latent noise is being sampled, and you'll see the video kind of generate as it goes. The other thing you need to make sure you turn on is if you go to the manager, there's a preview method here. Make sure you turn that to auto, and then you'll be able to see those previews down here. Okay, so now on to the optimization topics here. So first thing is the text encoder. This is what you want to use, the LLM and the clip. These are provided by KJ. You don't need to mess with these. The precision, so you can use either BF16 or FP16, but choose one or the other. And then you can play around with them. Maybe one of them gives you better results for some things and the other one gives you better results for others. Quantization, so you can play around with this as well. I typically keep it on, but you do get slightly better results by disabling it. But to me, it's not worth it for the amount of VRAM I lose to not have it on. Okay, so that is the text encoder. The custom prompts you don't have to worry about too much. If you do want to work with a different custom prompt or the default prompt, you can change that on this Hunyuan video text encode node. Quick note here, you're going to want to make that prompt template custom. I have it as disabled. That's a mistake. Make sure that you have custom as your prompt template. You can also use video, which is just as effective, but custom uses that custom prompt template that I'm attaching there. Okay, next thing we want to look at is this block swap node. So this is probably the most important one for VRAM management. What this does is it swaps blocks in and out of memory, in and out of RAM as you're sampling, which allows you to put less onto your graphics card, but also will slow down inferencing. So the fastest would be 0, but would use the most VRAM, and then the slowest is 2040, but uses the least VRAM. Okay, Torch Compile here. So Torch Compile is only compatible on the 4000 series of graphics cards. Like an RTX 3090 and below is not compatible. So depending on that, you can bypass this Torch Compile node or not. It does make a pretty big difference in how much VRAM you use. So if you have a 4000 series, that's advantageous. Yeah, so if you do try to use it with like a 3090 or something similar, you'll get an inductor error. So if you see that, then you'll know that you need to bypass this node. I have a LoRa in here just because I know a lot of you use LoRas, so I just wanted to include it in the workflow to show you how to hook it up. Now let's move on to the model loader. So this one we have a lot of options. You have the BF16 or the FP8 model. Typically, we'll stick with the BF16 model, especially when we use quantization, because the quantization allows us to kind of run BF16 with the memory of FP8, but it does degrade the quality a little bit. If you want to try it without the quantization, you will get better quality, but it is a big hit to VRAM. I think it uses like twice the VRAM, so you'll be able to generate like half the frames. So you can disable that if you have a large graphics card you're using. Also on 4090, you can use this FP8 fast. This just helps with faster generation, really, and it's worth it to use it if you have a 4090. Load device, you want to just keep that on offload device. Attention mode, this doesn't really affect VRAM usage, but it affects how fast we're able to generate. So keep that on Sage Attention. I made sure that in the install script, we have Sage Attention installed. If you're on Windows, it is more difficult to install Sage Attention. You need to use WSL, which allows you to basically run Linux in a container on Windows. You can install Sage Attention, and I use Linux, so I can't help with that, unfortunately, but I know there's videos out there on YouTube who where they show you how to install Sage Attention on Windows. The rest of these two, you can just leave those default. And then we have 3 nodes down here which are potentially useful. So the STG, I never really use it. I don't think it helps a whole lot. These two I do think help. So enhance a video, it's complicated because you can't just say like, oh, these are the best settings. You kind of have to play with it, and for all of your settings and your style of video that you're creating, you kind of have to adjust your settings to match you. But the weight obviously puts a stronger weight on enhance a video. Typically for larger resolutions, you can go for a larger weight, and for smaller resolutions, you need a smaller weight. And then the start and end percent it's kind of like IP adapter, where it will apply the enhance the video for a certain amount of the steps, and then it'll remove it for the steps after the end percent. And then Tcache is a node that increases speed at the cost of quality, but it doesn't. But it's less than if you just the quality loss is less than if you just decrease the amount of steps you're using. So you can play around with this. Again, it depends on the style of video you're creating, what value you can put in here, and it's similar where lower resolutions you typically need a lower Tcache value, and then larger resolutions you can get away with a little bit of a higher Tcache value. And just to describe a little bit of how Tcache works, it basically skips steps where it feels like the change in the latent from one step to the next isn't significant. So I don't know, that's basically what this threshold is setting, and I'm not 100% sure how they calculate it, but basically it's saying if the latents don't change by a factor of 0.15, and however they're calculating 0.15, then we're just going to skip that step, and then we're going to move on to the next step. Okay. And then the last, actually there's 2 more nodes to talk about here. So the first is the sampler. We really care about these first 4 for fitting within VRAM. So width and height, the recommended width and height for Hunyuan are 1280 by 720, and then 960 by 544. You can use any number of frames, and you'll get pretty good results. Up to, I believe, 201 frames is the limit. Once you get past 201 frames, it just repeats the video again. So for whatever reason, that is the limit to the length of videos you can create, which I believe is like around 8 seconds. And then your steps. So you start to see diminishing returns maybe around 15 steps. Between 20 and 30 steps, you're going to see very little change, and you're going to see a very large increase in how long it takes to generate. So I think 30 steps takes like 40 minutes or 30 to 40 minutes to generate, whereas 20 steps will only take like, you know, maybe 9 minutes to generate. So to me, that difference in quality, that minuscule difference in quality that you get isn't worth the extra, you know, 20, 30 minutes it takes to generate. And then embedded guidance and flow shift are the last two to really talk about here. These don't impact VRAM at all or the time it takes to generate, but flow shift will impact how much movement you get, or it should impact how much movement you get. Higher values should give you a bit more movement, lower values should give you a bit less. And then the guidance scale is kind of similar to CFG in regular stable diffusion. It controls how much, how well the sampler is going to follow the prompt. And last thing here is the scheduler. So this is actually a newer scheduler, this STDPM scheduler. This one typically provides best results. It's a little bit slower, but should provide you the most clean, crisp results. Okay, and then last thing to talk about is this Hunyuan video decode node. So you can try 256 if you have a large graphics card for the tile sample min size, but smaller graphics cards you definitely need to use 128 in order to be able to decode the video. All right, so starting with this 4 GB Hunyuan workflow, I'm going to run this and show you that we can in fact fit this within 4 GB. I am running this on an RTX 4090, but I'm able to see how much VRAM we used at the end. So let's run this and I'll show you where we can see how much VRAM is used. Okay, so that actually used slightly too much VRAM. That's 4.375 GB, so that probably would have gave you an out of memory error on a 4 GB card. But let's just drop the resolution a little bit and get it to fit within 4 GB. Alright, so there you go. There's about a 1 second video. It actually fit on 3 GB of VRAM, so we could fit a few more frames in here. But so that's essentially what you need to do when you're working on this. So decide what level of optimization you want based on the settings that I just described, and then adjust your resolution based on those settings. So so let's try another generation, and I'm going to go back up to the 960 by 544 resolution, and I'm going to drop our number of frames a bit to make it fit. Okay, so I mean, this is a pretty good quality generation for, you know, it only took 47 seconds. This is a 4090, so it's probably going to be a little bit slower on whatever graphics card you're using if you only have 4 GB, but it's a pretty solid generation for that small of a card. Okay, so now that we did the smallest possible, I want to move on to doing a 24 GB VRAM generation. So let's download the 24 GB workflow, and we'll drag that into our environment. And so this one will allow me to do a full 1280 by 720 video, 121 frames. Let's run it. It's going to take probably 20 minutes for this to run, but I'll come back and show you the results when it's done. All right, so that actually only took about 10 minutes, but we got a pretty good generation. Some of this like graininess comes down to seed luck, and some of it, you know, if I reduce my T cache, I have it at 0.5 here. If I turned it down to, you know, maybe 0.15, it would get less of this graininess. So I wanted to increase my speed because I didn't want to wait 30 minutes for this generation, but I sacrificed some quality there. All right, so that is pretty much it. Go to my Patreon and download the workflow for your graphics card size. Plug it right in, and it should work. The one caveat I want to just say is that not every single setup is going to be the same, and if you have different installs or different custom nodes, you may see slightly different results. So just play with those variables that I told you about, the block swap, number of frames, and you should be able to fit the video into something close to what's in your workflow. It may not be exactly perfect out of the box. I tried to get them close, but like I said, depending on your setup, you may see slightly different results. Okay, so if you have any questions, leave them in the comments. I really appreciate all the support that you guys have given me so far. And if you haven't subscribed, subscribe. I'm starting up an Instagram channel, The Artificial Trainer, just to kind of show you some of my generations and what's possible with AI right now. So follow me on there, and I will see you in the next video. Thanks for watching.